How are you doing today? Hope you're doing well. Sounds like so far things are going well. I've heard that a number of you have been complaining that this part is too easy. So don't worry. We'll make sure that we have a difficult homework problem for you tonight. Uh, so never fear. We'll give you something more challenging to do. But yeah, I think that um, I'm not entirely sure why. Um, Data structures is usually perceived to be a little bit easier of a week than algorithms, for sure. I don't know if that's because they're more static. I guess you're trying to understand things in place rather than things in motion, if that makes sense. Um, but yeah, it's also a good break to have after algorithms, and that's kind of an important part of instructional theory. Is that the difficulty of any given lesson should be, and for us it is, to a degree, something that's tuned. And it's good to have things that are very challenging because you learn the fastest that way, but you risk burning out or failing. And it's good to have things that are a little less challenging because that helps solidify your knowledge and feel better about uh, what you've learned and demonstrate what you've learned, and that solidifies your confidence. Um, so today we are going to do breakout rooms, as I said. There's 108 in here right now. I've said the word breakout room, and no one has left yet, although I did warn you to begin with, and I feel like we're 12 or so short from yesterday. These kinds of exercises are really important. Someday, at some point in time, you're going to want someone to pay you a very large amount of money to do this job. And to convince them, you're going to need to sit down and talk to them about how you work and how you think and how your code works, so that you convince them that you do know all of the things that we know you know because we've been moving you through the program. And things like this are an excellent time to practice that. Again, like if I'm sure you've seen the memes. There's one on Reddit this morning, even. Let me see if I can find that real quick while I'm talking. But there's memes about what the job is, and I've had days pretty recently where I'm programming, where I do 4 hours of research and I write one line of code and it doesn't work. So I reevaluate, I apply what I've learned, and I continue researching, and eventually I get to the solution. The other thing is that you have colleagues and you work with people and you talk, and so conversation and communication is one of the most important things of this job. And this is the practice for it. This is what we really do when we get stuck on something, when we're trying to figure something out, when we're doing it. I don't think I'm going to be able to find this. Yeah. Oh, and now yesterday I broke Google, and today I've just broken Reddit. Sorry. But anyhow, it's just a funny picture. But a lot of the time, the job is just sitting and thinking, and you don't want to sit and think for too long. It's good to test stuff out too. But this job is not sitting by yourself, isolated and alone, and banging on your keyboard with stuff that you just know. It's problem solving. It's figuring things out. And what we're gonna do, you guys are cracking me up in the chat this morning. What we're gonna do is we're gonna practice that, and we're gonna do. We should be able to get through 2 very classic interview problems today. But just to start out, let's do this. Let me ask a question. I'll ask it in the chat. If you could, a couple of you have requested that we answer these questions in threads, because otherwise there's so many people in the class, it can be hard to find things later. So I'm going to ask a question. If you could respond, create a thread for this one. This is a tricky question. Which is better, a linked list or an array? Yeah, Jason got it in first, and Michael is, well, right behind. It depends. It depends on what we're doing. So let's keep this thread going. Let's stay in this thread here. When is a linked list better? What kinds of things are linked lists specifically better than arrays? What are the advantages? Let's keep it in the thread again. Still, the old thread. Insertion and deletion when you need to add items. We're on the right track, but where? Where when we're adding? Yeah, at the beginning or at the end. In the middle, it's actually the same as an array, and the reason for that is that it's the opposite of one another, because the operation to delete something that you know where it is from a linked list, what's the runtime complexity of that? O of 1, right? Because all we have to do is switch the pointers. But what's the runtime complexity to find that thing? Because we don't know where it is, so it's O of n to find it. We have to iterate through the whole list to find it, and then we can delete it. And arrays are, of course, well, what is the runtime complexity to delete something from an array? The operation of deleting something that you know where it is, what's the runtime? That's O of n. Why is it O of n? What do we have to do when we delete something from an array? Yeah, we have to loop and shift. We have to get rid of that space. We're not allowed to have that. And we'll see a little more why later on. But what's the runtime complexity to find something in the array? This is a little trickier of a question. It could be O of n or it could be O of 1, right? Depending on if we're just accessing it by the index, it's O of 1. If we have to search for it, then it's still O of n. All right. So we've done your homework tonight. If you are doing a stack, which is better to use, an array or a linked list, and why? If you want to program a stack. I'm asking you a trick question again. Why is a linked list better for a stack than an array is? What makes the linked list better? Because it's easier to work with the first element. We only need to access the first element. Or Jonathan has it, both could work, because where do you add things to a stack? And where do you remove from a stack? How do stacks work? Could be the head, could be the tail. But a stack is first in, first out. So you're only ever operating from one side of the stack, right? If I have, I don't think I have anything stackable that I could show you. But if I'm stacking pieces of paper on my desk and then taking some off and then adding some back, then taking some off, I'm only ever operating off of one end. So yeah, first in, last out. Last in, first out. Right. Did I say it wrong? I have trouble with things like that. You don't want me navigating when we're driving. I'm really good at figuring out routes. I just might tell you to turn the wrong direction. Sorry about that. Thank you, Michael and Zachary, for catching, and everyone else who caught me with that. Who put the Pringles back? Yeah, like a Pringles can, although who puts them back? Um, so it doesn't actually matter. Uh, how about a queue? Which one's better for a queue and why? A stack, or I mean, I'm doing horrible today. I'm sorry. A linked list or an array? Linked list, the time complexity is better because you're accessing both ends. Thank you, Jason, Emma, Joshua, Kyle, Derek, Michael, Matthew, Min, Kyle. Yeah, because a queue is first in, first out, right? So we add from the back and we remove from the front, just like a line. All right. Okay, it seems like we're warmed up. We're remembering how this works. So here's what we're going to do. I'm going to give you an interview problem, and we're going to work on it in small groups. We'll use the breakout rooms for that. What approach are you going to use to solve this interview problem, and what approach should you use to solve any of these problems? Polya is the old, what we used to call it. We call it Uper now. Understand, plan, execute, and reflect. So let's move out of that thread now, since we're switching topics. Sorry, this is a new idea, and I'm trying to figure out how to mechanically run it. So Uper. So what we're going to do is we're going to start out with the first stages of that, which are the most important, which is to understand and plan. And this is critical because if you don't understand the problem, then you might solve the wrong one. And recently I've done that twice and been very angry with myself. One of them I wrote the code, I solved the problem, and it was talking about basically finding the distance between two elements in an array. And because I didn't understand the problem and I didn't read closely enough, I missed the fact that they wanted the absolute value of the answer, not positive or negative. And I couldn't for the life of me figure out why it wasn't passing the last test. And I was very frustrated. Another one that I did maybe a month or two ago when I was looking for a problem for another lesson, I got confused and I made an excellent, very clever little piece of code to find palindromes inside of strings, palindromic substrings. It was beautiful, worked perfectly. It's one of the most elegant things that I've ever written. Unfortunately, the problem was not asking me to find palindromes. The problem was asking me to find anagrams. And I was very confused until, what should you do? What should you do if you are executing and you get stuck? Something's not working and you're confused. You don't understand why your solution isn't working. Go back to you. Revise, make sure you're on the right track. Again, like all things programming, it's iterative and cyclical. It's not a linear process. So what we're going to do, this is a long-winded way of saying, we're going to start out with the understand and plan phase. So what I would like you to do with the groups after I give you the problem is to come up with a plan and pseudocode it, or at least write it down in terms of like a general approach. Like, we are going to solve this problem by subdividing the arrays into subarrays and whatever. That's not relevant to this one. Because as you know, in this week, you are banned from using Python's list, which is Python's implementation of a dynamic array. So hint for what you should be using to solve these, and that's actually in the problems itself. So any questions before I give you the problem, which I will read out loud and then drop in the notepad, and then I will send you to your groups. All right, well, if you think of any, ask them here. I will be closely monitoring the channels while this is going on. remember, we have a short amount of time with this, so accelerate the 20-minute rule. If you're truly stuck, ask for clarification, ask for help. But also remember, you've got a group, so talk about it with one another, discuss ideas. So we'll do this for a little over 20 minutes. We'll do at 45 after is when we will stop, and then I'll get some volunteers hopefully to share their work. Then we'll go and code it. All right, so the problem is, how can you find, sorry, I should actually read the actual problem text. How would you find and return the middle node of a singly linked list in one pass? You do not have access to the length of the list. If the list is even, you should return the first of the two middle nodes. You may not store the nodes in another data structure. Tricky question, real quick. If I say, yep, Sean, we're gonna share it in just a second. If I say A equals 1, or A becomes 1, if I type that, here, I'll type it here. Have I created a data structure? No, that's just a variable. That's fine, that's allowable. But if I say A equals that, have I created a data structure? Yes, I've made an array. All right, I'm gonna post the problem here and in the notepad so it's easy to find. And I am sending you to your groups. Wow, that's a lot. If you have any problem, if you get lost, if your group, I can't control who ends up in what group, and your team leads will be in there too. So if you end up with like alone and all the team leads staring at you or something, let me know and we can move things around. Otherwise, I will see you all in about 20 minutes. Awesome. Looks like several of you have gotten a coded solution, which is great. But for the first part, we're still doing the understand and plan phase. So Jonathan, would you like to share your plan? It looks like, I love that you've done a whiteboard here. Let me, now I'm, hold on. All right, so let's do Jonathan and then Julie. And for those of you who are ahead, we can see how you're feeling about your solutions, and then there'll be another chance to present actual solution codes in a little bit. Let me find you in here. All right, Jonathan, you are, you should be able to unmute yourself and share your screen and talk about what your group came up with.
Okay, sure. This was whiteboarding, so I don't know if I have access to it. I dropped the screenshot of it, so maybe I can just like, I don't know.
I think if you just open that up, then you can share.
Okay, let me try doing that.
If you share your whiteboard again, it might also still be there.
Let's try it. Let me see. No, I don't think that's there. Let me try to just share my monitor, and I can just pull up that image. Okay, here we go. So this was kind of what our group was doing. We like did a whiteboard and we drew out the two different cases. One of it's like an odd, a singly linked list with an odd number of nodes, and one that's even. And I don't know, we talked through some different approaches, and then I think some people were trying to do a little bit of like maybe research or Googling, and then some ideas we had were like counters or pointers, and we settled on this idea of traversing through the singly linked list with kind of like 2 pointers. One that would kind of go to the next node, and the other one that would go up by 2. And we try to kind of talk out the pseudocode. I don't know if this works. We might be off on something, but the idea that like while like this kind of pink faster node, it needs to have, or there needs to be a value at next and a value after that. So while fast pointer.next and fast pointer.next.next, well, those are truthy. We move up the current node is like the slow pointer that just goes to the next one. And then once the code exits the while loop, we return the current node. So we didn't get a chance to like test this or anything. We might be missing some.
That's cool. We're gonna have time. We're gonna have time to actually code it out after the break. So this is fantastic. I love this because again, let me make sure I'm looking at the chat so I can see. Oh, Kyle has a question. Yeah, Kyle, what's your question? So while Kyle is, there we go. So Kyle, that's a great question, and that's why this is a challenging problem, because I trust that after more than 20 weeks of training, you can all write a program that divides by 2. So, in the current solution, that's a fantastic question. Sorry, Kyle. So Jonathan, how do you know in your solution when you've what the middle is?
Well, I don't know that you need to know the length of the singly linked list for this particular solution, because you're just kind of like moving through it. And again, it's like the idea that there's 2 pointers moving. One's moving twice as fast, and so when the twice as fast pointer has finished traversing the list, the one that's moving at like half that speed. I don't know if these look like the one that's moving slower, that's moving one at a time, will be at the middle. And the way we visualized it is that, like drawing it out this way, is that it'll start if it's an even number of nodes, it'll stop at like the first of the 2 ones in the middle. And so if we wanted to calculate the length of it, we could probably add a counter. And then just when it kicks out of the loop, we could like double whatever, however many times that the current node has moved. Like, I guess that's one way we could find the length that way. Yeah, but I don't know that it's necessary to find the length of the list in order to find the middle using this implementation.
Awesome. Great answer to that. And also, Gustavo, you have an excellent question. Would this be considered 2 passes? Or Emma says it's 2 variables in 1 pass, and that's subject to debate. I mean, none of this stuff is fixed or hard. And so in these kinds of interviews, if you're able to, that's the kind of question that you might want to ask. Like, I have this approach. Would this, before I code it out, can you tell me if this approach meets the spec? And they'll like that, because again, the whole point of doing all of this is not to find out if you know the answer to the standard codified code problem 237, and you've memorized that and all the other 3,000 ones. It's how do you think? How do you problem solve? And I love this because you worked as a group, you drew it out, you talked about it, you came up with a good solution. Let's see, who else wants to share? Thank you, Jonathan.
Thank you.
We had, wait, I don't need to ask that question because I've already asked it. Julie, let me find you in Zoom. All right, Julie, you should be able to unmute and tell us the approach that your group came up with.
Okay, our approach was almost identical to Jonathan's groups. I think the only difference was that we set our slow pointer to head as well. And so we were incrementing, okay, so the slow pointer is going to be head.next, and then the fast pointer is going to be head.next.next, and then we added some conditional logic to our while statement. That would be that while fast pointer .next is not equal to none, then we're going to keep on going. And as soon as we don't, rather than return current node, we return slow pointer, because that way everything's just getting reassigned as we go.
Awesome. That's good. I saw some of the groups that posted code had a slightly different approach. Steve, do you want to talk about that? Let's save your code for later, but do you want to talk about your approach? Let me find you since you did volunteer to talk. Steve, if you're still up for it, can you unmute and just sort of tell us how your approach works in general terms without doing the specific code just yet?
Yeah, so if you look at the bottom of that thread, I posted kind of our thought process, which is using X's to represent nodes. And we pointed both the current and the middle to the head node. And we quickly realized that, especially since you're trying to find the middle, dividing the list in half, or the node tree in half, essentially is going to give you your middle point. So we decided that every 2 times our current variable was capturing a current node, the middle would move 1 time. So for every 2 of the current node, the middle would move 1 time.
All right, awesome, thank you. Great work. So let's see, let's do this. Let's go ahead and go on our break now. And then when we come back, we'll do the breakout rooms again to code these solutions. If you've already coded your solution, you can refine it or do something else productive. But if not, no worries at all. This is a hard problem. It takes time to do it, and it takes time to actually write it out and run it and make sure that the way that you have it set does run. The one last thing I want to address before we go on break, though, is some of you asked an excellent question of why can't we use the length function? And I didn't want to type this because I didn't want to sound like I was being, flippant or mean. But in a lot of these problems, as you're seeing with this one right here, the answer is what length? What length function? You haven't written it yet. And so, sometimes you start with a blank slate. You're not given anything. You've got to write not just the code to solve the problem, but the scaffolding around it to demonstrate the problem. John, I will add you again. And if anyone doesn't end up in a group, just either direct message me or at me in one of the class channels, and we can fix that. But another question that's interesting, that I think is interesting about this, that I'd like you to think about as we go into the break, is what is the runtime complexity to find the middle node of a singly linked list in one pass? What's the runtime complexity of that problem? So O of n. O of n. But here's where it gets tricky. What's the runtime complexity to find the middle node in a singly linked list in 2 passes? Remember, John, you can do it quicker, but we're talking about trends in general. But if you have a solution that is faster than O of n, I'm really excited to see what you're going to come up with in a little bit. But yeah, it's O of n. We're still walking the list twice, but it doesn't matter how long the list is. We do 2 times that number. How about 10 passes? If I give you 10 passes to solve this problem, what's the O of n? I mean, I answered the question. What's the runtime complexity? It's still O of n. It doesn't matter what the constant is. And that's because time complexity is different than how long it takes to solve the problem or how many steps it takes to solve the problem. Time complexity is how that changes when you add more of the same thing to the problem, which is tricky for sure. All right, I've rambled on to our normal break time anyway, so let's take the break. When we come back, we will code out our solutions, and then we will do another problem after that. And then at the end, we'll do a quick solution for a queue and stack. As always, if you have questions, ask them in the channel. Otherwise, see you in a few minutes. All right, everyone. First off, let me message everyone, make sure they see that we're back. There's a great discussion thread going in here. Kyle, thank you for asking that question, and thank you everyone for digging in and participating. This thread right here is what the job is. And sometimes you're the person who doesn't understand what's going on or how something works and you need help. I've been that person many times, and sometimes you're the person who explains or who does understand it. And then tomorrow, the day will switch, and it doesn't matter, where you are, who you are. The more your career progresses, though, the more stuff you'll learn, and the more you'll be able to contribute to that. And then sometimes you're wrong. And that's really cool to see a thread with 37 replies. So that's awesome. Very cool. All right, here's what we're going to do now. We're going to spend 20 minutes to a little less than 20 minutes to stay on schedule to code up a solution for that. And again, we're not giving you anything, which means you have to code your own demonstration. You have to create your own list node class and decide what else you need to do for it. And then we'll do the same thing and present those. Then we'll do another problem. And then again, as promised, we'll do the real quick solution for queue and stack. Any questions before we go? All right, again, if you don't end up in a breakout room, message in Slack and we will get you taken care of. I've created a thread to ask for volunteers. Please reply that if you'd like to share your coded solution. No volunteers for this one. Here we go. All right, Michael, let me find you in Zoom. All right, Michael, you should be able to unmute and share your screen and show us what you've got. And then on deck, we've got John. If you want to talk through a solution, we can do that as well. Curious to hear what you have.
I didn't actually have linked list coded on my end. It was on my partner's computer that we had the linked list set up.
Oh, who is your partner? And or they should be able to share their screen too, and I can give them unmute abilities if you want.
But the codes, yeah, it was, I'm not sure how to say his name, Rowan's, but he followed up. What we had in our group was slightly different than what I had.
Okay.
But same algorithm, just different variable names essentially.
All right, this is everyone. The code is in that thread asking for volunteers. If you want to take a look, and do you want to walk us through what it's doing and why you did the things you did?
So sure. Set the first node. Do you want me to share? Just kind of walk through it line by line.
Yeah, just walk through.
All right. So set the current node, and that would be like the fast node, the one that goes twice as fast, to the head of the linked list, and also set the middle node because we're just going to use 2 pointers over one iteration over the list. Then the first thing we do is we actually iterate the current node by 2 so that one's always leading the middle node, because the middle node, when we have even values, needs to be the lesser of the 2 middle values. So If the fast node is leading, then that means that the middle node will follow after it's already been evaluated. The while loop just checks to make sure that current node is not none. If it's not, then it increments the middle node by 1 and attempts to increment the fast node, current node, by 2, at which point it'll reevaluate the while loop. And if the fast node has hit none, or if it has a value, if it hits none, then we're done. If it has a value, then it increments the middle node by 1 and then attempts to increment the current node by 2 once again. And when we're done, we just return the value.
All right, awesome, thank you. John, let me, all right, you should be able to unmute. Tell us what you're thinking about this one.
Okay, I like that solution very much, and I also like the one that was presented before the break. But what I would do to improve it, it assumes that you can move by 2 in a linked list, but I would actually increment it more. I would increment it 1. So let's pretend that I'm just using the same code that Michael just showed, but my fast loop would be a lot faster because it would increment first by 1, then by 2, then by 4, and it would keep doubling until it fails because it goes beyond the list. And as soon as it fails, then I would reverse it and have it until I get to the end quicker. And that would allow me to get the information back of the length of the list, and that would just go into the other piece to show where the middle is.
John, I think that would be an awesome solution, and it would be log-in for a doubly linked list. But with a singly linked list, you can't go backwards because we don't have the links to follow in the other direction.
Okay,
So,
yeah, I didn't know, couldn't you just tell the first piece where the middle is and then just have it increment there after you have the information?
I think I'd have to see it out in code. You should try coding the solution with a singly linked list. It's on a good approach, and whether or not it actually works, that's the kind of great thing to talk about in an interview. Because again, the whole reason why we're having you do all of this stuff is we want to help you learn how to make things better and faster and talk about finding those solutions. And just because, whether or not it ends up working, it's always good to be questing and looking and talking for better ways to do things. So thank you for sharing that, John. That is awesome. Steve, you should be able to unmute yourself and show us your group solution.
You want me to share my screen?
Yeah.
Okay. We tried to code out the class stuff. I'm not sure if we got all the way there or not. Ended up having to copy and paste some of the other stuff because we ran out of time. But basically, to find the middle, we're setting a counter, initializing it to 0, declaring a middle variable for storing the middle node, initializing it to the list.head, assuming that there is one, and then setting a current, which is equivalent to other people's fast and slow nodes. Our current would be our fast, and our middle would be our slow. And then while there is a current.next, so something after head, then we would increment our counter by 1, and then reassign current to the next node. And then if the counter modulus 2 is equal to 0, then we would reassign the middle to middle.next, which allows our fast and slow trackers to stay at the right rate to stay in pace with the middle, to locate the middle, which is this content here.
Awesome. Very cool. And what both groups have showed us have done variants of what's called the fast horse and the slow horse, or the tortoise and the hare. And it's kind of the classic solution to this problem, where just by having one go twice as fast as the other, by the time the first one gets to the end, the second one will naturally be in the middle, and you can just return that new. This is, of course, tricky because with a linked list without a metadata class, which we weren't given for this problem, you know, all we need to have a linked list is just the head node. And the other stuff is useful, but optional. So yeah, pointers everywhere. Exactly. All right. Here's what we're going to do. We're going to take 25 minutes to do this. We're going to plan and code out a solution to probably the classic interview problem, which I will paste in the channel in just a moment. But the classic interview problem is, in one pass, how do you reverse a singly linked list? How can you reverse a singly linked list in one pass? So take it, turn it around one time through. I would say FizzBuzz is not an interview question so much as a early lesson. It's like what you learn after learning Hello World. All right, let me share that. Let me share that. I will open up the rooms and I'll share that in the channel. As always, if you have questions, ask away. All right, everyone, welcome back. Looks like most of you are still here. Thank you for that. Who wants to share a solution? No one? Here we go. Kyle, well, let's test it together then. Kyle, I'm guessing you're just Kyle in here.
Yeah.
All right.
All right. This is a pre-used linked list, so don't worry about all this right here. To reverse the list, the idea was that if we had simple numbers of 1, 2, 3, and 4, the first idea was that we just go till the last node, and then we would move that back. But then if you did that, we would get what would it be? 3, 2, 4, 1, which wouldn't be reversed. So you actually want to take your current node, which would start at 1. You want to go to the next node and put that next node in front of your head, and then have that next node point to the head, which then would make your current node the next node after the head. So we're going to move our next node in front of the head, put the next node pointer to point to the head, and the head pointer will then move over to the next node after that. And then you would get 2, 1, 3, 4. And you would keep doing that operation until the current node's value is none, because then you will have effectively moved all of your items in front of your current node or your starting position, if that makes sense at all.
I think so. I think that's a clever and unique solution to it, if it does work, which it looks like it will.
So what I did, the logic in the code then is we just set current node. So current node will always be true. So
Right.
if current node next node is not none, then what we need to do is make the current node dot next node equal the next node. So we started at 1, 2, 3. So the next node needs to not be 2, but we need to move that pointer to 3. And then after that, the head value is going to be a node, which is current node dot next, which would be 2. And then the head value dot next node equals the current node, which that pointer would then point to 1. And then we keep doing that over and over again.
Super clever. I love it.
And then if the current node dot next node is none, break.
That's awesome. You should definitely get that running. Make sure that it does work.
Okay.
It's a little different. It's fantastic. So Jason, no, it's not different than what I was looking for. It's different than I was expecting. The thing about programming is that there's many, many different ways to do anything. And so a lot of these problems have classic solutions, and all of our repos have reference solutions, but they're not the way to do it. They're a way to do it, which is a very different thing. The classic solution, which we don't have time for, but if you want in your one-on-ones, you can get the code from your team leads, is to do pointer manipulation. And it's kind of a juggling game where you use a couple of placeholder variables to go through one at a time. And you essentially, all you're doing is you're just flipping the pointers, which I think conceptually is not that hard, but actually doing it, you go one at a time and you juggle and flip the pointer back one at a time. So you have a lot of ugly variable names like you know, this dot next dot previous and this dot previous dot previous dot next dot previous dot next dot next dot previous. And I like that because it's a problem where it's a good effective solution, but it's kind of ugly. And sometimes our problems are like that, which is something we're going to encounter tonight. So the homework tonight is to do the LRU cache. Make sure you follow the problem-solving framework with that carefully. In particular, keep in mind that this is a hard problem, and I can tell you that this is one of those problems where it's hard to figure out the solution to it, but the solution itself is not that many lines of code. But try to do a ground-up approach, an iterative approach, and break it down into pieces, figure out what you can get done, and then add to that to meet the requirements. Again, no using Python's built-in list for this. We're using our linked list class. And yeah, if you have any questions, let us know. Otherwise, thank you for the great participation with the breakout rooms. That is the last we will be doing it this week. So for those of you who hate that, congratulations. For those of you who love it, sorry. And I will see you all around. Bye-bye.